The topic I will be covering is the Fermi paradox. The Fermi paradox is the apparent contradiction between the high probability extraterrestrial civilizations' existence and the lack of contact with such civilizations. So where are they? The simplest solution with the Fermi paradox would be saying that we didn't observe anything due to the fact that there was nothing to observe. We are alone in the galaxy, or at least, we are the first to have reached the threshold of technology. Exploration, colonization, survival. If there's another source of intelligent life out there, then it would want to spread itself beyond its planet of origin. Exploration will consist of sending a mission towards other stars once they've reached that level of technology, whether it's by curiosity or for prestigious reasons. Colonization. Since the beginning of times, this has been the underlying goal of most civilizations, for religious reasons as well as for economic or political reasons. And last but not least, the final reason, survival. The lifespan of a star in a stable form is limited. For example, in approximately 5 billion years, our sun will no longer be a stable star, which we know. It will become a red giant that will probably absorb the Earth. Sooner or later, space and interstellar flights will prove to be essential to the extraterrestrial civilizations and even humanity's survival. Are we the only technologically advanced age of the universe? The Drake's equation are based on multiple factors, such as the fact that there are an estimated 250 billion stars in the Milky Way and 70 sextillion in the visible universe. The Drake equation states that n is the number of civilizations in our galaxy which we might expect to be able to communicate at any given time. R is the rate of star formation in our galaxy. Fp is the fraction of those stars that actually have planets. Ne is the average number of planets that can potentially support life per star that has planets. Fl is the fraction that actually go on to develop life. Fi is the fraction that actually go on to develop intelligent life. Fc is the fraction that are willing and able to communicate. L is the expected lifetime of such a civilization. Based on current lower estimates, this ends up equaling 0.0000008 civilizations in our galaxy. The question then arising and famously formulated by physicist Enrico Fermi in 1950, since only one extraterrestrial civilization could spread in a relatively short time, how is it possible that we never saw the extraterrestrial ones? The radio telescope Arecibo, located in Puerto Rico, has been sending radio waves into space since 1963. Radio waves have many advantages. First, they move at the speed of light. It takes them only 4.3 years to reach Proxima Centauri. Secondly, they are easy to generate or receive and at a low cost. Lastly, they are not disturbed by the galactic magnetic field and, for a wide range of frequencies, absorption or diffuse is very weak. So what are the conditions a planet must meet to accommodate life? First is the size of its orbit. Then it's the distance from the star to the planet. Too near, like with Venus, and the planet would receive too important flow of energy and would become too hot. Too far, like with Mars, and would not receive sufficient energy and would be too cold. Here are some possible answers to the Fermi paradox. Life is difficult to start and to evolve to an intelligent and technologically advanced stage, and we are the only one in the galaxy. And last but not least, advanced civilizations destroy themselves on short timescales.